Hello everyone and welcome to another video on general physics. Our topic for this video are vectors and vector addition. Alright, so imagine any random thing, just some kind of a rock. It has physical quantities. Of course, since we're talking about physics, it has physical quantities. Two kinds actually. One are scalar quantities, scalar. Two are vector quantities. When you say scalar quantities, it's just magnitudes plus units. Yun lang yan. Vector quantities are also magnitudes plus units plus a direction. Okay, so it's directed towards somewhere. Okay, so that's the difference. There's a measure of somewhere in vector quantities. Examples of scalar quantities: mass, temperature, time, speed. And vector quantities, we have force, displacement, velocity. Those are vector quantities, and these are scalar quantities. Okay, let's delve deeper into vectors. Vectors, they're denoted by capital letters like big F or F with an arrow on top. So we will be using emboldened capital letters a lot in physics, especially dito sa libro ninyo. And then we will use the form below to specify the direction. First, the degrees. It says north or south of another direction. Okay, may baka nakakalito siya. It's an example is like just like this: 37 degrees north of east. Okay, diba? So that's it. That's a vector, and it is denoted on the graph like this. So 37 degrees north of east, diba? North of east. At this is east, and north is pataas, to the north of east. So that's a vector. 12 degrees south of west is another example. 12 degrees south, it's downwards, in the downwards direction of west. 12 degrees south of west. This is west, and that's your vector. 12 degrees. That's it. Those are vectors. Okay, now let's go to performing operations on vectors. The very first is vector addition. Vector addition has two kinds. Two ways to perform vector addition. One is graphical, another is analytical. Graphical, meron tayong parallelogram method. We also have the polygon method. Analytical naman, we also have two. First is with laws of sines and cosines, and the next one is the component method. Okay? Now, the resulting vector from adding vectors is called the resultant vector, or just the resultant. So whenever you see these two terms in your book, in your exams, it just means the result from adding two vectors. Yeah, resultant vector or the resultant. Let's go with the parallelogram method. How do we do the parallelogram method? Okay, suppose you have a given. Ito yung given natin. Dalawang vector. Two vectors, 3 meters northeast, 6 meters west. Okay, how do we add this graphically using the parallelogram method? First, observe strictly the size of each vector with regards to its magnitude. Okay, yung size niya, yung 3 na yan, yung 6 na yan, it matters how long you will draw it on the graph. It matters. If you draw it na mahabang mahaba, maybe it's not equal to 3 meters. If you draw it na maikli lang ng ganyan, maybe it's also not equal to 3 meters. So that's very important, number one. Larger magnitude equals a longer vector to draw. A smaller magnitude, shorter vector to draw. Okay, so very important yung numbers. Okay, number two, draw the two vectors to be added from the origin as the sides of a parallelogram. Okay, we'll draw them from the origin. So vector number 1, there you go. Vector number 2, there you go. Okay, we drew it from the origin as two sides. Okay, two sides yan. Can you already see the parallelogram? It might need a little imagination. There you go. See? two sides of a parallelogram. 1, 2. And then, we just completed the parallelogram. Diba? Okay. Draw the diagonal of the parallelogram created. So, we created this figure. You draw the diagonal. And that is your resultant vector. That's it. So, number 4, determine the magnitude from the scale used, the graphing plane. Okay, so use a ruler. You measure gano'n yan kahaba. Okay, so it matters how long it is, ano? And when it says yung scale, that's just the difference between etong cells na to. Yung iba kasi, maybe you'll be using a scale na it increments by 2. So, 2, 4, 6, 8. Yeah. So, it depends on the scale of your graphing plane. But of course, if you want it to be much easier to measure with a common ruler, just follow the scale of a ruler. For example, one box ng ganyan is 1 centimeter each para it's easier to measure with a ruler. Okay. Number 5, use a protractor to find out the angle. That's it. You find the resultant vector that way. Diba? Okay. Draw the sides. Complete the parallelogram. Draw diagonal and measure this diagonal. Okay. There are some examples for using the parallelogram method on your wonderful book on page 33. Okay, so try. You could pause this video and try it for yourself. Okay, and if you have some questions, maybe it could be answered by reviewing the previous slide, the video. You can rewind the video. You don't have. I can't go back to the slide, but just rewind the video. Okay, let's proceed. So graphical, polygon, head to tail or tip to tail. So these are other names for the polygon method. Okay. Suppose naman we have tatlong given, A, B, C na vectors. Okay. Observe strictly the size of each vector with regards to its magnitude. Again, it's very important how yung magnitude of these. Yung 3, yung 6, yung 8. Obviously, itong vector C will be the longest among the 3 kasi it's 8 meters. So that should show up in your graph. Number 2, draw the first vector. Start from the origin. That's very important. Start from the origin. That's vector A, 3 meters northeast. And then draw the next vector. Start from the tip of the previous vector. So from the tip, we draw the second vector. And then keep doing this until you have drawn every vector. And there you go. That is vector C. Okay, we drew it from the tip of the last one. After drawing every vector in number 3, draw one more vector from the origin to the tip of the last vector. This is now the resultant vector. Okay, that just means where you started, you connect it to the last one. That's why head to tail, head to tail. Diba? Tip to tail. This is the tip. It connected to the tail. There you go. That is your resultant vector. Determine the magnitude from the scale used. So again, use a ruler and then use a protractor. So measure this, okay? So it's going to be something degrees south of east. That's it. Some examples and exercises are found on pages 34 to 35 of your wonderful book. You can pause this video and try it out for yourselves. Okay, now, dun naman tayo sa analytical. Okay? So, in explaining the law of sines and cosines, first imagine a generic triangle. It's just a generic triangle. It's any triangle. Any triangle has 3 sides, A, B, and C. Any triangle has angles A, B, C. Okay? And let's partner it. Let's have a little parang convention, parang tradition na the small a is opposite the big angle A. Small b opposite the big angle B. Small c opposite big angle C. Okay. The law of sine says na small a divided by sine big A divided by sine big A is just equal to B divided by sine the angle B equal to C divided by sine angle C. Ayan yun, the law of sines. So you can manipulate these equations to get the value of something that you don't know. Law of cosines naman, actually, if you cover this, this is like the Pythagorean theorem only. Ito. But this is the more accurate way of writing it. So the law of cosines. So it just says na, for example, you don't know what the value of small a is, but you know what B and C are, and you also know the angle A. Ito. So these are the partners, A and these three. If you know these three, you don't know small a, you can calculate for A. Just put the value of B, value of C, BC, and the angle A here. And use a calculator. It's probably going to be impossible to do this without a calculator. And the second equation, it just says na, if you don't know the value of small b, but you know these three, you can use the law of cosines to get the value of the small b. Small c naman, small c, you don't know the value of this. Pero for example, you know the value of these three. You can use the third equation. You can use the third equation to get the value of small c. So that's the purpose of law of sines and cosines. So why are we showing this? Kasi if you use this on vectors, sometimes you'll be able to create triangles. Okay, when you create triangles, especially with just two vectors lang, when you use two vectors, when you're adding two vectors, you're going to create a triangle. The polygon that you will create is a triangle. So use the law of sines and cosines there. So some examples and exercises are on pages 36 to 37 of your book. So try it out, and meron ding explanation in the book. If you're having a hard time understanding, read it more slowly. Siguro, don't rush it. I believe that you can do it. Okay, it is the last part. The last part for vector addition, the component method. Okay, before we start doing the component method, you have to understand what it means about the resolution of vectors. When you say you resolve vectors, it just means that the vector that you are computing, you split the vector into its x and y components. When you say resolve vectors, you're dividing it into its pieces, what it's made of. That's what resolving is in vectors. Okay. Resolution of vectors. Okay, to calculate the x component of a vector v, also known as the horizontal component. Okay, the horizontal, ayan, yung flat na yan, is this. So this is your vector, the magnitude of your vector. You multiply it by cosine theta, the angle that it makes with the x-axis, that will be the x component of your vector. And to calculate the y component of a vector v, also known as the vertical component, it's just this. The y component is equal to the magnitude of the vector times sine theta. And theta is, again, the angle it makes with the x-axis. That's it. Itong dalawang to, these two equations, that's it. The direction of your vector will determine the sign of your components. Okay, so now we have three vectors. Vectors f, d, and t. Okay? So yung x component niya, itong f, is ito lang, and y component. How did we get this? We got this by substituting 4 into this, 4 times cosine 45. Where did I get 45? Because this is 45 degrees. Northeast, it's exactly northeast, so that's 45 degrees. You try it out with the calculator, and you'll see na lalabas yan. Okay, and the vector d naman, 2 meters west. You substitute yung 2 meters into this. Yan. 2 times cosine 0. Why is it 0? Kasi look, wala namang angle. There's no zero angle, di ba? It's flat. It's flat on the west direction. So 0 yung angle. And bakit negative 2? Kasi if you substitute this into this calculator, you're going to get positive 2. So why is it negative 2? Kasi yung direction, it's towards the negative, di ba? It's towards the negative, so yung x mo would be negative. This one, how about this one? Vector t, 4 meters, 15 degrees south of east. So yung x component niya would be 3.86. Substitute this into your formulas here. For cosine 15, you're going to get 3.86. Try nyo naman, dito sa y component niya, 4 times sine 15. And you're going to get a positive. So, bakit negative yan, sir? Kasi, look at this. It's downwards, diba? It's on this quadrant right here. It's in this square of a quadrant na yan. Nandiyan siya. If you look at the y, ayan o, it's there negative. So, your y should be negative. Okay, I hope that's clear. Analytical, the component method. Proceed tayo. So, first, you resolve all the vectors. So, this is on page 40. Itong sample na to. It's on page 40. You can check. So, first, resolve all vectors. Split them into component parts. That's what resolving means. So, we have 4 vectors. Itong A, B, C, and D. This is resolving them. Ayan o. We resolve them. We split them into horizontal, into vertical, to X, into Y. That's it. Step number 2, add all the components together. Okay? Add all the Y components together. All the X, all the Y together. Ayan, natin mo. Look at this. Ayan o. That letter, parang big fancy letter E na yan. It means summation, right? Sum. You add all of them. This one, the same way, add all of them. So that's all what this means. So it looks fancy, but that's just what it means. You add all the X together. So from the first X to the second X to the third, all the way to the whatever X. Yan, add mo silang lahat. And then add nyo rin lahat ng Y. The first Y, the second, the third. What I mean by that is the first, the second, the third, all the way to the whichever Y. Add them all. So that's all for step 2. Okay, tabi natin yan. Step number 3, use the Pythagorean theorem to calculate for the resultant. Okay, so it looks fancy, pero for this example, look, ganyan lang siya. It's much simpler. It looks fancy, but it just says na whatever you got here, whatever value, you put it inside. Whatever value, you put it inside. Yun lang yung nangyari. See? This value, inside. This value, inside. Diba? Very easy. Number 3, solve for the angle of the resultant vector. And this is, ganito lang yan. Yung angle, you just do it on a calculator. Tangent inverse multiplied by the absolute value. So, dapat positive ha. The absolute value of your y divided by your x. Your y divided by your x. Dapat positive ha. Should be positive. If it's not positive, then make it positive. That's what the absolute value does, right? Remember? Okay. So, then you get the tangent inverse of whatever shows up here. You will get the angle. Some more examples and exercises are on page 40. So I hope you try it out for yourself. And that would be the end for this video on vectors and vector addition. See you on the next one.